Hey guys, welcome back. Here is our second day of rational expressions. We did the basics yesterday and covered multiplying and dividing, and today we're going to cover adding and subtracting. So here's the deal. You may remember this back from when you first learned how to deal with fractions when you were really young, in middle school at some point. If you are going to add or subtract fractions, the most important thing that you need is a common denominator. You cannot do anything unless the denominators match. So one of the biggest things that we'll go over today is making sure you get that common denominator before you do anything else. When you are making the denominators common, what operation do you use? You're always going to use multiplication to get to that common denominator. So this list here is kind of a checklist for what you need to do, but rather than spending too much time going over these steps, I'm just going to leave this here for your reference, and I'm going to explain as I go through and do a few problems. So for the first problem here on the bottom, we want to perform the indicated operation and simplify. This is an addition problem, and right now when I look at the denominators, they are not the same. This is just a monomial denominator. There's no plus or minus in there, so I can multiply by whatever I'm missing. This fraction has ab squared. This fraction has a squared b. So if there's an a squared here, there has to be an a squared here. If I multiply by a, that would make this bottom turn into a squared b squared. Okay, but now this side only has a squared b. So this side needs a b in the denominator. The thing is, you can't just randomly go decide to multiply denominators by anything you feel like. Whatever you're going to multiply by in the denominator, you also have to multiply by in the numerator. So this first fraction needs to be multiplied by a over a. The second fraction needs to be multiplied by b over b. Why are you allowed to do that? Because look at what you're multiplying by. This is basically the same thing as just multiplying by 1. You're just making it look different. So what we're going to do here is if we multiply by a, the top I need distributive property. The top would become a squared minus ab. On the bottom, I have a squared b squared. I'm adding that to this fraction, which if I multiply the top by b, again use distributive property, this time I have ab plus b squared, and that's over, again, a squared b squared. So now my denominators match. If my denominators match, I'm now allowed to add these two fractions together. So I keep that common denominator, a squared b squared, and I combine like terms on the top. So I have a squared, then I have minus ab and plus ab. Well, they cancel each other out. And then I have plus b squared. And that's it. I can't do anything else with this. The top has a plus in between, the bottom does not. These do not match. I cannot factor anything. This is my final answer. Good, and I know to some of you, I'm just going to mention it, this might look like I can factor the top, but I would only be able to factor the top here if there was a minus in the middle, because there's a plus in the middle that's not factorable. Okay, and we're going to work through a couple of other examples. So here's the second one in this same family. Here's my dining room table again. Example number 2, we need a common denominator. I can't see what's in common or not yet. I will have to factor what's here. If the denominators are binomials or trinomials, you have to factor before you try to put anything together. So this bottom, I can factor. That's the difference of two perfect squares, x plus 6, x minus 6. This one can be factored also by a GCF. I could pull out an x and I'm left with x plus 6. So now if I need to have a common denominator, I have to figure out what's missing from each of these. So the first fraction has an x plus 6 and an x minus 6, but it does not have an x. So I have to multiply the top of this first fraction by x over x. And then this second one, after I factored, I'm left with this. I have the x and the x plus 6, but I don't have the x minus 6 that's over here. So I have to multiply by x minus 6 on top and bottom. So now let's see what I have. When I multiply this through, on the top I get 2x. On the bottom I have x times x plus 6 times x minus 6. And then I'm subtracting over here. I would have x minus 6 over, and again I have x plus 6, and x minus 6. Now with subtraction, you have to be careful. It's very sneaky. You are subtracting all of this. It's almost like distributive property. So when I go to put these together, I have the 2x from the first fraction, then I have minus x, and I have minus negative 6, which turns into plus 6. That is now over that common denominator of x times x plus 6 times x minus 6. Now, when I combine what's left here, on the top I have x plus 6. On the bottom I have x plus 6, and x minus 6. This problem still needs one more step. The x plus 6 up here can cancel with the x plus 6 down here. I can replace the one on top with a 1. I can't ever just wipe out an entire numerator. The best I can do there is put a 1 where a numerator used to be. So my final answer to this problem is 1 over x times x minus 6. And that is my answer. Some people have a desire to distribute down here on the bottom. You can do that if you want to, but you certainly don't have to. Then we're going to talk about a special trick that happens with a problem like number 3. On number 3, what you should notice is that the denominators are so close to being the same thing, but there's something very critical that's different about them. They both have a 2x, they both have a 6. They're also both subtraction, but the order has changed. We need a common denominator. There is a shortcut to doing this, and the shortcut is, if you want to change just the order here and keep it a minus in the middle, you can just multiply by -1. And remember what we said before, anything we multiply the bottom of a fraction by, we also have to multiply the top by the same thing. So that means this is now 3x over 2x minus 6, plus this is now -9 over 2x minus 6. So now I have my common denominator. This little trick makes your life much, much easier than it would be otherwise. And now I can combine like terms. So on the top I have 3x minus 9. Oh, no like terms. I could just write them next to each other. On the bottom I have 2x minus 6. Now if you're not sure whether or not you can cancel anything there, you can't cancel anything the way it's looking right now, but you can always factor first and then see. So when you factor up top, you can GCF factor out a 3, leaving you with x minus 3. And on the bottom, you can factor out a 2, leaving you with x minus 3. So what does that mean? That means you do have something else to cancel. The x minus 3's can go. Final answer to this problem would be 3 over 2. And then finally, you have one last problem. When you look down to the bottom, it almost doesn't look like a fraction problem, right? You have a fraction, but the other part isn't a fraction. What you can do is you can take this whole first expression, the k plus 2, and put it over 1. So now you do have two fractions that need to have a common denominator. And so I can just multiply this by k plus 2 on top and bottom. What that does is it makes us a mess, but it does get us a common denominator. Because the top of this first fraction would now be k plus 2 times k plus 2, which you're going to have to actually go through and do, over the k plus 2 on the bottom. And then the second fraction, you have that minus there, is 4k over k plus 2. So now I have common denominators, but before I can put these fractions together, I have to multiply this mess out. So if you don't like to do it in one step, or if it's too hard for you to do in one step, you can take that over to the side and do your multiplication the way we did it with boxes when we reviewed it last week. K plus 2, k plus 2. This becomes k squared plus 2k plus 2k plus 4. Or you could do FOIL if you're used to FOIL from last year. And then when you combine like terms, this now becomes k squared plus 4k plus 4 over k plus 2. And you're subtracting 4k over k plus 2. Now what does that do for you? Well, since you have your common denominator, you can now keep that common denominator. And on the top, we have k squared. We have 4k and negative 4k, so they cancel each other out, and then we have plus 4. This can't be factored, either one of them can't be reduced. And so k squared plus 4 over k plus 2 is your final answer. All right, so that's your review of adding and subtracting fractions. Biggest important takeaway from this is you have to get yourself a common denominator before you go and try to put things actually together. Now, like I said to you yesterday, my advice to you, I didn't assign this as a separate homework, but I would like you to treat it almost like that. Shut this off for a few minutes. Here, I'm done for a minute. I'll take a rest. Shut me off. Pause it. Go do the problems. There's only 6 of them. And then come back and check your work against mine. Please. Because that way you'll know what you really understand and what you don't. Okay? So hopefully you've done that. You're just coming back to me now, and now I'll go over how to do these couple of problems. So this was your practice. I hope you have them all right. Here goes. What do I need here for a common denominator? Well, they already both have a y, but this one has a 2 and this one has a 3. So I can multiply this fraction by 3 on top and bottom, and I can multiply this fraction by 2 on top and bottom. Why would I do that? Because that way the bottoms of both will be 6y, and that's my common denominator. Now if I multiply the top here by 5 times 3, I get 15. Multiply the top here 4 times 2, I get 8. And then you just have to actually do your subtraction, and so you end up with 7 over 6y. That should be your answer for practice problem number 1. Practice problem number 2, you can't do this problem until you factor the denominator that you already have. This is factorable. So the first fraction is 4 over x minus 1, but the second fraction now is 5 times GCF, x times x minus 1. So we have x minus 1's in both places here, but we are missing this x over here. So if we want to put that in and make this x times x minus 1, we also have to do that on top. That means I now have 4x over x times x minus 1 plus 5 times x over x minus 1. Lovely. Now I have my common denominator. The best I can do is write them together. Sometimes you'll actually be able to add the terms on the top, but this time we have unlike terms, so we are stuck with this exactly the way it is. There's nothing else to reduce. We end up with 4x plus 5 over x times x minus 1. Okay. Moving on to number 3. Well, at least this one I don't have to factor, right? Those are already lowest terms. But we're missing things. We are not allowed to add. Like, we can't just do plus 4 on here. It's not the way fractions work. We can multiply by anything we want on top and bottom. So what we're going to have to do here is multiply the first fraction by x over x, getting me to 3x over x times x plus 4. Plus this one I have to multiply by x plus 4 on top and bottom, so that way my bottom will again be x times x plus 4. My top here, I can use my distributive property, will be 2x plus 8. And then you can just put these together. We end up with 5x plus 8 over that common denominator of x times x plus 4. There is nothing here that will cancel, nothing else that will factor, and that is my final answer to number 3. Moving on to problem number 4. This is that special case like we saw back in the lesson a few minutes ago. The bottoms are almost the same 2 terms, minus sign in the middle, but the order is reversed. You just have to pick one of them and multiply by a -1 on top and bottom. I usually do it to the second one. So now I have x squared over x minus 7 for the first fraction, and then I have -49 over x minus 7 on the second. When I put these fractions together, I have x squared minus 49 over x minus 7. Now this problem, I ended up with something on top that can be factored. So now you go ahead and factor that. That is difference of 2 perfect squares, x plus 7, x minus 7, over x minus 7. And now the x minus 7's cancel, leaving you with x plus 7. Now you are allowed to cross out the whole bottom. You can put a 1 there and write it as x plus 7 over 1 if you want. But because it was the denominator that got knocked out, we can just leave that alone. All right, we are getting down to the last 2 problems here. On number 5, the first fraction here, this bottom can be factored, right? If GCF of 4, you'd be left with x plus 2. Lovely. So they both have a 4 on the bottom, but this fraction needs the x plus 2 that the first fraction has. So I'm going to multiply by x plus 2 on top and on bottom. That will allow me to now have 3 over 4x plus 2 that I'm adding to x plus 2 over 4 times x plus 2. And when I do that, on the top I have x plus 5. On the bottom I have 4 times x plus 2. That is messy. There's a lot of parts to it, but there's nothing else we can cancel, so we are stuck with it. And then we are up to the very last problem for today. And on this one, again, I'm going to have to factor the bottom. This is that trinomial, backwards FOIL, whatever you want to call it. This factors to x plus 3 times x plus 2. That's my new denominator. This denominator has a matching x plus 2, but it doesn't have an x plus 3. So I'm going to multiply by x plus 3 on top and bottom over here. When I do that, my first fraction now looks like this, 4 over x plus 3 times x plus 2. My second fraction looks like this, 3x plus 9 over x plus, it doesn't matter, but I would make it match the order on that one, so x plus 3 over x plus 2. And then when you combine like terms here, you have 3x plus 13. So none of these were pretty enough to have to factor again at the end. All of these were pretty straightforward. Once you get your common denominator and you add your numerators, there's nothing there to factor, so there's nothing else to do. And that is your final answer. And so there you go. That's your practice with adding and subtracting fractions. So all we're going to do here is you're going to look this stuff over tonight. I think I'm going to give you the review sheet tonight also. Maybe I'll attach it to that email when I put that together in a couple of minutes. So you'll see it's just some practice with the stuff from yesterday and today. And then tomorrow I'll put up the quiz for you. We'll get that out of the way, and then you can get started on your final project. And I'll be emailing you the directions for that as well. So that's it. Have a great rest of the day, guys, and I'll talk to you soon. Bye-bye.